Making of an electromagnet. To know this concept, first we need to know something called magnetic effect of electric current. Alright, to know this, when a current flows through a conductor or a wire, it produces magnetic field around the wire or the conductor through which the current is passing or flowing. It means when the current is flowing through a wire or a conductor, there's magnetic field produced around that conductor or that wire. For example, you can have a look at this. I have a wire AB where the current is flowing from A to B. Can you see this arrow? So here the current is flowing from A to B. Now, when the current is flowing from A to B, there is magnetic field produced around this conductor, that's AB, okay, which I have shown in the form of concentric circles. You can see these circles, that's called concentric circles. So the magnetic field which is produced looks like concentric circles here. So when a current is flowing, this magnetic field produced, and this magnetic field here looks like concentric circles. So this confirms when a current is flowing, there is a magnetic field produced around that conductor or the wire. Alright, so let's proceed further. Okay, now suppose I take a wire, okay, and wound it around an iron or nickel or any other magnetic substance, including few alloys, okay, which I'm not going to talk much about them. Okay, so then when a current is flowing through that, those materials like iron, nickel, or the few alloys which I'm talking about, they starts behaving like a magnet, temporary magnet. Okay, and this is called an electromagnet, everyone. So till the current is flowing, till the current flows to the iron rod, okay, it behaves like a magnet, and once switches off, iron rod behaves like a simple iron rod. I have shown this here. You can see there is an iron rod here, and I have taken a wire which I have wound around it. You can see it, and which I have connected with a cell and a key. So when the current is flowing, when switches on, the current starts flowing. So this iron rod which is there, that starts behaving like a magnet, which we call it as electromagnet. So this iron rod, till the current is flowing, this iron rod is going to behave like a magnet, and which we call it as electromagnet, because here the magnetic field or the effect which is produced in the iron rod is because of the electricity. So electromagnet is made up of two words, electricity and magnet. So because of the electricity, when there is a magnetism produced, we call it as electromagnet. So today's concept is how to make an electromagnet, everyone. So this was the little bit information about the electromagnet, and then we are going to switch over how to make an electromagnet. Okay, so to make an electromagnet, what are things we require? We require a spool of wire, everyone. You can see that this is a spool of wire. I have a big length of wire which is here. Then you need an iron nail or a screw, big one, little longer, and then you need a cell or battery, and you need a rubber band, okay, just to put it around for a safety purpose. So basically you need 1, 2, 3, 4. I'm going to tell you how to make an electromagnet. Okay, for that what you need to do is you need to take this screw, okay, and you need to take this wire, okay, spool of a wire. And what I'm going to do is I'm going to start winding around this nail, everyone. All right, so after finding this, You can see that I have got two ends now. Okay, I've wound this entire spool of copper wire around this nail, or you can say screw, a long screw. Now I have got the two ends. Now these two ends I'm going to connect across a cell or a battery. This, okay. So what I do is I take one end here that's negative, and the other end that's positive. And when I connect negative and positive ends, and if I take it near to, can you see that the pins are connected? I want you to see the pins are connected here. Can you see? Yes, you can see all the pins are connected nicely. Now, okay, so when I release it, one end, you can see that they start falling. But can you see that there is one still connected, though the one end is out of the, and if I remove this entire battery, still you can see that one is here still connected. Do you know the reason behind it? The reason is that this nail got little more magnetized, and it is keeping its magnetism for a little longer, and after some time it is falling. Look at this here, why this was possible, because look at my turns. I have got very high number of turns here, very high number of turns. So for this I take you to the concept here. If you remember the concept I taught you here, the magnetic strength which is out there depends on two things. Magnetic effect depends on two things. Number one, it is directly proportional to current. Magnetic strength directly proportional to current. If I have more current, more will be the magnetic strength which is going to be produced. And magnetic strength is also directly proportional to the number of turns. So here I have got more number of turns here, so the magnetic field which was produced was more. But suppose I have one cell, if I connect one more cell to it, obviously the amount of current which is flowing will be more, and when the amount of current flowing will be more, the magnetic field which is produced is going to be more. So this was all about for a making of an electromagnet. Thank you very much. We'll see you in the next video. Thank you so much.